1 over x plus 2. The domain of this function is negative infinity union negative 2 infinity. The vertical asymptote is at negative 2. Therefore, x equals negative 2. The horizontal asymptote is y equals 0, because the degree of the numerator is less than the degree of the denominator.
Y equals 0 when the degree of the numerator is less than the degree of the denominator.
We're going to plug in the x values 3, negative 3, 2, and negative 1, because those values are not restricted from the domain. And remember, x cannot equal negative 2. One over 3 plus 2 is equal to 1/5. 1 over negative 3 plus 2 is equal to negative 1. 1 over 2 plus 2 is equal to 1/4. And lastly, 1 over negative 1 plus 2 is equal to 1. Now we're going to plot the points. X squared plus 3x over x squared plus x minus 6. And the numerator is going to come out to be x parentheses x plus 3, and the denominator is parentheses x plus 3, parentheses x minus 2. X over x minus 2, and x cannot equal negative 3.
Horizontal asymptote, when degree of numerator is equal to the degree of denominator, y is equal to the leading coefficient.
The vertical asymptote in this problem is x equals 2. The horizontal asymptote is determined by the coefficients because the degree of the numerator is equal to the degree of the denominator. Therefore, y is equal to 1.
Because there is an x plus 3 in both the numerator and denominator, there is an existing hole at x equals negative 3. Now we start with 1. 1 squared plus 3 times 1 over 1 squared plus 1 minus 6. Is equal to negative 1. 3 squared plus 3 times 3 over negative 3 squared plus 3 minus 6, which is equal to 6 over 2, which is equal to 3. Negative 2 squared plus 3 times negative 2 over negative 2 squared plus a negative 2 minus 6, which is equal to negative 2 over negative 4, or 1/2. Negative 1 squared plus 3 over negative times negative 1 over negative 1 squared plus a negative 1 minus 6 equal to 1/3.
Oblique or slant asymptotes. Degree of numerator is greater than the degree of the denominator.
Example 3, 2x squared over x plus 1. The degree of the numerator is one or more degree than the denominator, therefore a slant asymptote exists. X plus 1 will be your divisor, whereas 2x squared will be your dividend. Be sure to include placeholders, those are important when dividing. The way to approach this is, what can you multiply x plus 1 in order to get 2x squared? 2x times x plus 1 equals 2x squared plus 2. Be sure to change the sign. You are left with negative 2x plus 0. What can you multiply x plus 1 in order to get a negative 2x? Negative 2 times x plus 1 equals a negative 2x minus 2. Be sure to change the sign. Your quotient 2x minus 2 will be part of your slant asymptote. You have a remainder of a positive 2, which now becomes your new numerator, and your divisor x plus 1 will remain as your denominator. When a slant asymptote exists, you will only have vertical and slant asymptotes. There will not be any horizontal asymptotes. A slant asymptote, you graph it like a regular line. Two